so really what we're talking about today are exponential functions, okay? Exponential functions, okay? And in our first set of notes, we looked at these. We've seen these before. We've seen this stuff before. Here's growth. This is a y equals 2 to the x, and we've seen decay. This is y equals a 1/2 x. We know that if the base is bigger than 1, it will grow. We know if the base is less than 1, it will decay, all right? So we showed the graphs of those. We showed the fact that it will never, ever become 0, so you get a boundary at 0 called an asymptote, okay? It will never become 0, never touch the graph, so it gets a boundary line called an asymptote, okay? Now, number 1, growth or decay. This one's got to be decay, because the base is less than 1. This number 1/12 is less than 1, so it has to be decay. Now, we don't have to have a perfect sketch of it, just the right shape. So for me, if I just need the right shape, I'm going to go ahead and try and put my graph down and get a little bit of an idea of what it looks like. Okay. It always goes through 1, unless there's a number in front of it. So this graph is going to look something like this. We don't have to have a perfect graph, we just need the right shape to show decay. All right? It has to go through 1 unless there's a number in front of it. And there is not a number in front of it, so it's going to be, there's a 1 right here we never write. There's a 1 right there we never write, and that's why it goes through 1. Okay? Okay, number 2 is definitely growth.
Growth.
Because the base is bigger than 1. So again, I don't have to have a perfect sketch of this. So I'm just going to go ahead and make a graph. And if it's growth, it's going to have the same appearance, but going the other way. It has to go through 1. Has to go through 1 and look like that, right? Doesn't have to be perfect. We just need the right shape, and it has to grow, all right? This is growth because the base is bigger than 1. Again, if I graph it, it doesn't have to be perfect. It's going to be maybe a little steeper than the last one, because it has a bigger base. Has to go through 1 because there's a 1 right here we never write. Might be a little steeper because it's a bigger rate, right? Number 4 is decay because the base is less than 1.
Wait, could you, because these are, what's the word for everyone x has only one y?
Functions. They are functions, yeah.
How would you find their mirror?
They do. They have an inverse, and it would be the flip over this, okay? Yeah, it does have an inverse. Yeah, Nikolai?
I don't understand the first one. 12 is bigger than 1 and 1 is equal to 1, so how can we decay?
No. Not 12, but 1/12. 1/12 is a fraction. 1/12 is a number. It's very small, isn't it?
But it's 7. What is 7 over 2?
3.5. Okay? All right? So, here we go. So, example 5. Let's take a look at it. The number of bacteria Y in thousands in a culture can be approximated by the model 100 times 1.99 to the t, where t is the number of hours the culture is incubated. So first of all, this has got to be growth. Okay, Ben, you watching?
Yep.
This is definitely going to be growth. So the bacteria are going to be growing, right? It says, tell whether the model represents exponential growth or decay. Well, we know it's got to be growth because the base is equal to 1.99, or the base is greater than 1. So it's got to be growth, right? It's growing in a sense at 99%, okay? Identify the hourly presence increase or decrease in the number of bacteria. So it's growing at a rate of 0.99, okay? 0.99. Okay, now this is important you see the difference. And we've talked about this before. The 1 represents the initial population. Let's go back to banking. We talked this about banking, okay? If you don't have the 1, let's say put money in the bank, if the 1 is not here, you don't get your original amount. You need the 1 to get your original amount. Then the 99 is your increase. So what we get is 0.99 or 99% increase, okay? Estimate when the number of bacteria will be over 1 million. So to estimate, there's 2 ways to do it. One is guess and check. We've got our y equals 100 times 1.99 to the x. We're just going to plug numbers in, okay? But we got to be careful because I think it said something about in thousands, right? In thousands, right? So what we really are looking for is when this thing, see 1 million in terms of thousands, huh?
Which should be like 100, then 200,
So, yeah.
400 basically.
Well, let's put some numbers in. 100 times 1.99 to the power of, let's try 5, okay? Okay, are we at 1,000? We're not at 1 million yet, are we? So, let's keep going, let's estimate. Yeah, that's going to be, yeah. So, let's take this piece out. I don't want to confuse people. Let's take this out for right now, okay? All right, Aiden? Because that'll really confuse people, okay?
Yeah, it won't confuse me.
Okay, I know, but it will confuse. Okay, so are we at 1 million yet?
No.
Okay, so what do we want to try? What do we want to try next?
10.
Okay, try 10.
Yeah, 10.
433.7.
Oh,
Okay, are we at 1 million yet? We're close. What do you want to try next?
11, 12.
10.5.
I bet 11.
Just do 11. 11 would easily get there. 10.5.
It doesn't go the whole 5.
Million doesn't get there yet with 12, so what do you want to try next?
15.
15?
Come on, Ben, 11
Wait,
would
what
easily get
happened?
there. 16.8.
I'm
Okay, we're over 1 million with 15, right?
Oh,
That was
try
900 or 973,000.
14.9.
Now, what if we graphed this, what if we graphed it, might be better, if we graphed it, and then we can use our trace button to figure it out. Okay, now watch. I'm going to do it another way. I'm going to do it another way, because this is just guess and check, guess and check, guess and check, right? So if I graph it, let's go to y equals, and I'm going to put in my 100 times 1.99 to the power of x. Okay, now watch. Okay? If I graph this, it's going to be better than guess and check. Watch. Okay? So if I graph this, now I probably need to change my window. What do I need my y value of my window to be? My y value needs to be
1 million.
1 million, right? So let's make it 1 million, maybe 100,000. So I got a little bit extra, right? Okay, graph. Okay, now I need to check my x value. So I know my window is 0 to at least 15, right? You guys agree we want at least 15?
Yeah.
Okay. Now, if you go to your trace button, and we're looking for 1 million, right?
The n be 1 million?
Okay, let's see. I'm right at
whatever it is on the x-axis.
17,000 here. So let me keep going on my trace button until I get closer and closer to 1 million.
Just hold it. It works. That's why it's working.
Okay, I've got, where am I at? 140, 142, 3, 4, 5, 6,
Close.
8. There's 1 million, right?
13.4.
13.4. How's that?
That's an estimate.
It is still an estimate, yeah.
Will stuff like this be on the quiz tomorrow?
No.
Good.
Okay, no.
Tomorrow's, yeah, the quiz is Friday. Tomorrow's the late start.
Good, I got rid of it.
Okay, now, shh.
So it won't be on the quiz on Friday?
No.
Okay, I said tomorrow.
Yeah, I know you did.
That was confusing.
Recursive formula. Let's see if we remember recursive formula. So recursive formula needed A1. What's A1? What's the first term?
2.
Yes. And then we say we make an AN is equal to, okay, 6 times A to the n minus 1. Okay, we haven't done recursive formula for a long time, but recursive formula, you always put down your first term, and then you tell what we're doing. We're multiplying by 6 each time. Okay? Okay, recursive formula. What's A1? 11. And then to make the next term, we're always multiplying a to the n minus 1 times 0.3. Okay? Almost done. Almost done. Okay? Okay, exponential growth. Okay, so, and they need the rate. So we're going to rewrite this. Am I going too fast?
Yeah.
Y equals, you'll get this as soon as I write it down, 1 plus 0.25 to the t plus 4, okay?
Yeah.
Okay, everybody created the 1 plus? So 0.25, 1 plus, okay? So my growth rate is right there, 0.25 or 25%, right? We need the 1, always need the 1 to get your original amount, right? Plus your growth rate, okay? This one is going to be decay, so we're going to rewrite this as f of t equals, you ready? It's going to be a 1 minus 0.56 to the 7t.
That makes sense.
Okay, because that's how I get a 0.44, right? Okay, that's how I get a 0.44. So this time I'm losing, or I have a decay rate
This is less than
of
1.
0.56, right? Okay, yeah. All right, so I've got a homework sheet. I'm going to stop recording.